Hello, Haiyan.
Hi, Michael.
So very nice to make this update about the SiComb project now, and you're the coordinator from the DTU on this SiComb project. So one thing now, when project has been running for a while, can you first of all present a little bit what is the project about to remind us and the general public?
Okay, so in SiComb project, we are exploring silicon carbide as a new material platform applied in integrated photonics. The reason we are doing this is because silicon carbide has a very unique optical property, which could outperform the existing material platforms such as silicon dioxide, silicon nitride, indium phosphide.
Yes, and I think this is the basic idea because silicon carbide is traditionally used for power devices, so that's the main activity so far. But this other type of application, this is unexplored, so this is why it's a FET, Future Emerging Technology Project. So it's very nice to hear about that. And now a project has been running almost it's 2 years. So what is the status of projects and partners, and what is going on?
Yeah, despite the bad influence of the coronavirus, in fact, all the partners are putting a lot of effort in this project to uh, achieve the results as we have planned. In the project so far, we have already quite a good number of joint publications, and these joint publications are based on the collaboration of the material growth and the device fabrication. For example, the DTU as the device fabrication partner has received material from FAU and CNRS, and we have optimized the fabrication process at DTU. We achieved and we understood a lot of new stuff of this new material in the optical applications, and we contributed to the conference abstract and also journal publications.
Yeah, so that's me as a materials background. I know how challenging it is to make new material concept because there's so many different things, and it's not easier when parts and things for the growth are delayed due to pandemic and so on. So I'm very happy to hear that there is the first movement of material to device, so on. And if we are looking into the future next things, project is still one more year or so, and then it will be finished. But what are you now looking into as a next steps, next activities of outcomes of the project?
Yes, I think look into the future. First, we are going to look more into the application side. For example, the device, especially the frequency cone we are developing in the project. We are going to implement it in the data center. And the challenge, in fact, for this project is to form the silicon carbide uninsulator stacks, which is not commercially available yet. And in our project, we have developed different technologies. And so in the future, we are trying to commercialize this technology. For example, we may look for EIC transition grant to support the production of prototype of silicon carbide uninsulator stacks. And meanwhile, when we are giving more results, we also started to interact more with the other EU projects which also work on the frequency comb by using other materials. When we know there is a deadline for the EIC transition application next spring. So before we submit the application, we are also going to study the market potentials in order to come up with a strong proposal.
Yes, this is very nice to hear that already the positioning into the future thinking, it's really great that the researchers are targeting that and so on. So this is looking forward to that. So now I think we have gotten brief overview of the project and what it is about and what is happening and what are the next phases. So I thank you very much for that, Haiyan.
Thank you, Mikael, for the interview.